Okay, everybody, this is section 3.6. We're going to take a look at some more things about graphs that are really important, kind of a follow-up to the increasing and decreasing that we talked about in 3.5, that part 2. So we're going to talk about critical and extreme points on the graph. So looking at some different things that can happen. So where things change direction, where important things are occurring on a graph. So we're going to start with critical points. So there's a definition here for us, so we'll take a peek at that. So critical points are the points on a graph where there's a line of tangency drawn to the curve that ends up either being horizontal or vertical. So we need to remember a little bit back from what point of tangency means, and that's where a graph meets the line of tangency at a 90-degree angle. So a line of tangency would be something like this. That would be horizontal, or like this would be a vertical line of tangency. So these points would be considered critical points on the graph. It's where the graph is changing direction, going from increasing to decreasing, things like that. So we're going to look for where those locations are on graphs, where those critical points happen. All right, so let's talk about the first kind of critical point that's really important. They're called absolute and relative maximum. So I'm going to go ahead and talk about what a maximum might be. So they have this big definition for it. When the graph of a function is increasing to the left of a point and then decreasing after it, they consider that to be a max. Well, that makes sense, right? If you're going up and then you go down, you have to reach a maximum value. Now, there's two different types of maximums, though. There's ones that we call absolute maximum, which means it's the greatest value a function ever has in its domain, the absolute biggest one. So you can't ever have a bigger one. That's the absolute maximum. And then you can have what we call relative maximums. Over some interval of the domain, it happens to be the biggest number, but it's not the biggest y value in the entire graph. So there's two different kinds of maximum points a graph can have. So for example, on this first graph, a parabola opening down, this point right here at 0, 4 would be considered a maximum, and not just a maximum, it would be considered an absolute max, because it's the biggest point on this graph that you'd ever have, because the end behavior, it would be opening down. So it's never going to come back up. So absolute maximum. This point on this graph, more like an odd power graph, this point here at whatever it looks like it is, -1, 1, 2, 3, 4, 5 maybe. So that point right there would be considered a relative maximum. Relative to the points around it, it is a maximum value. It's increasing and then it's decreasing. But there are points over here on the graph that are higher than it. The y value is bigger, but it's a maximum in its own interval of the domain. So kind of two different kinds of graphs. So we have absolute and relative max. Graphs could have both of those. They could have neither of them. They don't have to have these at all. So they can be multiple or none. All right, well, you can have the same thing, but for minimum. So when we talk about minimum values, look at the definition. It says when the graph of the function is decreasing to the left of it and then increasing. Well, if you go down and then you go back up, there must be a bottom. So that's called a minimum. And again, we have two different types. We have absolute minimums, where in the entire graph, that is the lowest point that you'll ever have. And then we have these relative minimums. That's where you're looking at there's other points maybe on the graph that are lower, but in that particular interval of the domain, it's the lowest value. Okay, so let's take a look again so we can talk about what that might look like. So on a parabola, 0, 0, great example in this case of a minimum, and not just any kind of minimum. This is the lowest point on the graph, that vertex, so it would be an absolute minimum. Let's take a look at the last graph that we had too. The same exact picture. We had a relative min or maximum. This one also has a relative min. This point at 0, 2. Relative to the points around it, it's a minimum. It's going down and then going back up. But there are certainly other points on the graph that are lower. All these points on this branch over here. So it's not an absolute minimum. It would be a relative minimum. So if we take a look kind of at the big picture here, a graph like this second one, there's no absolute anything. The graph continues to get smaller and smaller, continues to get bigger and bigger. It would have no absolutes at all. It only has relatives. So that's very common to what you'll see. I want to show one more graph, and I'm going to have you draw it. This is an x to the 4th sort of graph here. So try to make it so it's symmetric. It is meant to be. When you look at a graph like this, you can have more than one point that is an absolute or relative something. So we can have this symmetry going on in the graph. So this one is a situation where you actually have two locations that would be considered absolute minimum. So kind of talking about what that would look like. So you can have multiple places that can take on that absolute, especially when it's a symmetric kind of graph. Okay, well, some graphs don't have max and min points. Think about some of your parent graphs. Like something like x cubed, y equals x cubed, that definitely doesn't have a minimum sort of point, right? Absolute, certainly not, or minimum or a maximum. So what's happening for these graphs? There's definitely something going on at that symmetry point. So when we think about 0, 0, that point of symmetry, there's a change in direction that occurs at that location. So it's curving in towards the origin and then it curves away from the origin. So if it's changing its curvature like that, that's an important point on the graph. We call that a point of inflection. Inflection has to do with the curvature. So if the curve is changing, that's an important place to look. When we graph x cubed, that symmetry point, that curvature change, is the place that we look for first. So some things don't have max and mins, but they still have important points on the graph, like a point of inflection. Okay, so I just want to make sure that you can identify by location, by ordered pair, and by name, like what kind of points do these graphs have, and then when we get to the graphing calculator, we'll be able to classify that for our graphs as well. So I want you to go ahead and pause the video and see if you can fill in the information. Where are the max and min points? What kind of max and min are they? So go ahead, pause, and see if you can locate those for this one. All right, so it looks like at this point right here, at -2, -1, we have a relative maximum. I'm just going to kind of abbreviate here. And then at this point, 1, -3, we have a relative minimum, because again, there's points lower. That's what the arrows mean. And then at 2, 4, we have an absolute maximum. There's no point higher on this graph, so it's absolutely the highest point that you'll have. And again, I know that because of the end behavior, what the graph is doing at the ends. All right, let's take a look at the next one. For this one, again, I want you to do the same thing. Go ahead and pause the video so you can try it yourself, and then double back and check and see if you're okay. All right, so on this graph, we have a point right here. That location looks to be about -1, 3, relative minimum, because there are points that are lower. At the point 0, 4, relative maximum. And then our point down here at looks like 1.5, -2, that would be an absolute min. No points lower than that point right there. All right, now next one, next graph, do the same thing. See if you can locate any extreme points. For number 2, go ahead and pause and do that. All right, so it looks like we have 1, or -1, -1, 2, 3, 4 would be an absolute minimum. So all of those kind of parabola type graphs will have an absolute, either max or min, depending on which way it's opening. Okay, so go ahead and take a look on the graphing calculator and type this one in. So go ahead on your calculator and type in x cubed minus 3x plus 4. And we're going to talk through how you locate where those maximum and minimum points are. I did put a picture of what it looks like on there, so go ahead and pause the video and type that in. Okay, now that you have it on your calculator, I want to show you how to find those locations. You can sort of eyeball it, which is great. I think you can kind of tell where those points are, but if they weren't whole numbers, we'd kind of be in trouble. So I want to make sure that you can see exactly where they are. So it's under the calculate menu, which is second trace, and it's going to ask you a bunch of questions here. So there's a lot of different things you can do. What we want to look for is number 3 and number 4, minimums and maximums. So the first point I'm going to do is going to be that one in quadrant 2. So that's a maximum point. So I'm going to go ahead and press 4. I want to do a maximum. You get a cursor, it's going to ask you 3 questions. Left bound means go ahead and put your cursor to the left of where the point is that you want to locate and press enter. And then right bound, you're going to press your blinky cursor guy to the right of where that point is, anywhere to the right, press enter. And then it asks you a guess. So I'm going to go ahead and arrow back, and I'm going to guess that that's where it is, get it close, and then it's going to give me a value. So it's going to give us a maximum point. Now, if you see this, like what's happening with mine, -0.99999, the graphing calculator has some weird limitations here. If it's like that, they mean -1. So it's a -1.6 would be the location of that maximum point. So it's actually going to be able to give you the ordered pairs. So even if it's not whole numbers, you're still going to be able to figure it out. And that would be a maximum, and it's actually a relative max, because there are other points that are higher on the graph. Remember, we have our arrows here. All right, now let's find the minimum over here in quadrant 1. So let's locate this point. I'm guessing it's 1, 2, but let's make sure we know that that's what it is. Okay, so we go back to calculate, so second trace. We want a minimum now, so number 3, it asks you the same 3 questions, left bound, right bound, guess. So go ahead and put your cursor to the left of where your point is, to the right of where your point is. You may notice too when you do that, it puts up little arrows on your calculator screen. So I get it close for the guess here. It puts up boundaries and kind of like putting up a fence. The little arrows pointing at each other is where the calculator is going to look for that value. So my guess, I'm guessing it's there. And we have it again. Here's doing this goofy thing again. So 1.000 whatever, they mean 1, so it looks like it's happening at 1, 2. So at 1, 2, we have a relative minimum. Okay, so we can actually find those points really quickly, really easily on your graphing calculator. So you enter it in and you can see what that does. Okay, so let's take a look at these last couple. So it says what kind of critical point is happening on the graph of this equation at x equals -1. Well, I bet you can kind of guess because of the parent graph, it's a parabola, and a parabola has a vertex. So if you had to guess, it's probably a what? Probably a maximum, but go ahead and graph it and see what it looks like so you can check and see what that graph is doing. So I'm going to go ahead and pause. You guys pause as well, graph it on your calculator and see what's happening. All right, so I have my graph up as well. So it looks like our vertex is happening at -1, -4. I'm going to guess that that's what it is. So if you want to see what's happening at x equals -1, probably the fastest way is to go to our table. So get back to starting at a reasonable number here. So at my table, I can check and see what it is at -1. Looks like it's -4. If you plug that in, you're going to get the same value. If you trace on your graph, I'm pretty sure that that's going to be right where that vertex point is happening. But you can also go to your second calculate, go to minimum, which is number 3, and do your little left bound, right bound guess. So to the left of where it is, to the right of where it is. See if it can get caught up to me here. Oh, I went too far. All right, and then guess, get it close. See how it puts up the arrows there. So I'm thinking it's about right there, so I'm going to guess, and sure enough, again, weird goofy thing, but -1, -4. So at -1, -4, just make a little sketch here, 1, 2, 3, 4, that appears to be my vertex, and it's opening up because there's no reflection, right? We have a +1, so that means -1, -4 is an absolute minimum. So it's asking you what kind of a point is it? It's a minimum, and it's absolutely the smallest point on the graph. So being able to identify where that is. Okay, last one we're going to talk about, I think that is the last one we're going to talk about actually for right now, being able to identify. So the assignment that you're going to be working on goes back to some of that continuity tests and then identifying the critical points. So max, min, absolute, and relative, being able to do both of those, being able to go through and find those values. I think the last equation question thing that you guys have on yours is maybe this. So I'm going to go ahead and go through this one. If you don't have this one on your note sheet, then you can just use it kind of as a review, I guess. Just to quickly talk about just some of those other things we did, end behavior, critical points, and increasing, decreasing. So kind of as a review. So go ahead and type this in. So pause the video, go ahead and type this one in, and then we'll talk about what's happening. All right, so here's my graph. What I'm going to do is go ahead and go to my table so I can see a view points to be able to actually graph, so you can do that as well. 0, 2 looks like something pretty reasonable. And then got to get back up here to 1, 1, and then 2, -4. So 1, 1, 2, -4, and I think that'll give us plenty to be able to see what's happening on this picture here. All right, so let's talk about what's going on in some of these things that we need to talk about. It looks like on this graph, let's start with end behavior. So we're going to do that, and we'll talk about increasing and decreasing as well. End behavior, y approaches what as x approaches positive infinity? Y approaches what as x approaches negative infinity? All right, so as x gets really, really big, looks like our y is going down. That's from the -3, so we're approaching negative infinity. As x gets really, really small, so going in this direction, what's the y doing? It's getting really, really big, so it's approaching positive infinity. So for end behavior, it's going down as we go to the right, it's going up as you go to the left, so it's reflected. Okay, let's talk about increasing and decreasing here for a second. For this graph, as you go left to right, this graph is decreasing all the way through. So I would say it's decreasing for all values of x. So from negative infinity to infinity, It is decreasing. All right, and now it certainly doesn't look like we have any absolute max or min points, right? Because we have our arrows, and there isn't any change in direction either in the middle of the graph. So somewhere in this location, it looks like we're going to have a point of inflection because it's just changing curvature. It's not actually making a max or a min. It's not getting bigger or smaller. So it looks like we have a point of inflection happening on this graph, this x cubed. So we have a lot of different things going on in that picture to be able to see what's going on for those. So just a quick review of some of those things. So increasing, decreasing, end behavior, being able to kind of put that all together. So the assignment tonight will be both of those things. So looking at those max and min points, finding them on your calculator, and still being able to look at end behavior in increase and decrease. So lots of good stuff about graphs.